7th grade lesson 8.1 is about similar shapes and scale drawings and how you can manipulate the scale drawing to understand how large the actual item needs to be. So scale drawings are blueprints. Usually architects will use blueprints. They're going to plan everything out before the builder starts building things, right? You want to do that. Or what a mess things would turn out to be. So they're always planned first. And so these sorts of jobs, you would need to be able to do the math in order to know the different measurements between the two, from the scale drawing to the actual item. So that's what this one's about. It employs tools that you're already familiar with, so let's go ahead and put those together. Let's first look at the explore activity because I think this acts as a really nice bridge into the tools that you're using. So as usual, we'll go ahead and read the information first. They say, just like I mentioned before, scale drawings and scale models are used in map making, construction, and other trades. A blueprint is a technical drawing that usually displays architectural plans. Pete's blueprint shows a layout of a house. Every 4 inches in the blueprint represents 3 feet of the actual house. One of the walls in the blueprint is 24 inches long, and what is the actual length of the actual wall? And they give us a drawing here. So we want to know what the actual length of the real wall. This is the blueprint, 24 inches on the little paper, but the real wall, how big is that going to be? And in order to know how big that's going to be, we need to know what scale factor they used, and they gave that information here. Every 4 inches represents 3 feet. And we can write that as a ratio. 4 inches is 3 feet. Remember, ratios could be written this way: 4 inches to 3 feet, or just 4 inches to 3 feet. Remember ratios from last year. So I tend to use them in this circumstance. I use them in fraction form. And you'll see what they did here is the blueprint length in inches and actual length is in feet. And they did a 4:3 ratio. You'll hear me call this a scale factor a lot. This is the ratio, the scale factor, that they gave us in the information. For every 4 inches, that represents 3 feet. So what they did here is they used a table to measure that. So for every 4 inches, that's 3 feet. If they did that times 2, then they get 8. Times 2, you get 6. 4 times 3, 12. 3 times 3, 9. 4 times 4, 4 times 5, 4 times 6, right? So we'll do 3 times 4, which is 12. 3 times 5, which is 15. And 3 times 6, which is 18 feet. So if the blueprint has the drawing as 24 inches and the scale factor they're using is 4 inches is 3 feet, then the actual wall will be 18 feet long. Now you might be asking yourself, what if these numbers get really big? Do I really have to do that table for the whole thing? No, if you remember, tables usually are using that idea of the equivalent ratio all the way across. Whatever you do to the top number, you do to the bottom number, right? We multiplied by 2 for this one. We multiplied by 3 for this one. And as long as we did the same to the top of our ratio as we did to the bottom of our ratio, then it stayed equivalent and we get our answer. So if we just recognize, how do I get from 4 to 24? Well, that's times 6. Okay, so 3 times 6, 18, right? That takes us into the very next part. So keeping in mind how that last one went, let's take a look at this one. And right before this word problem in your book, they talked about the scale drawing. It's a drawing that's two-dimensional, and it's a small version of whatever the main version is. So an architect's blueprint would be an example of a scale drawing. They also talked about scale, which like I said, I call it scale factor sometimes. That is that ratio, like we saw before, where it was 2 inches is 3 feet or something, or that's this one, 2 inches is 3 feet. You use that ratio to make the manipulations to find out how big the actual one or how small the small one, depending on which information you have. So those were the vocabulary words they went over. Let's take a look at this problem and go through the steps to solve it without having to draw out that big old table. The art class is planning to paint a mural on an outside wall. This figure is a scale drawing of the wall. So they drew it first on paper first. What is the area of the actual wall? Okay, they want the area, so we need to keep in mind we're going to want the area of the wall. Remember, area is length times width. So off to the side, let's just kind of remind ourselves we need to take care of that. And that's of the actual wall. So all we have is this drawing over here. We don't have the actual wall where we can go measure the length and the height in order to find it. What we have is, this is our given information, that on the drawing, it's 28 inches long in length and 11 inches in height. That's what we know. We also know the scale factor that 2 inches is 3 feet. I'm going to write it as a ratio 1 over the other. Okay. So I need, in order to find the actual wall is in feet. And I have this information in inches right now. The length and the height is in inches right now. So I want to change it to feet. So what I'm going to do is change this inches to the unit rate of inches. I want it to be 1 inch. So obviously in order to get 2 to become a 1, it's 2 divided by 2, right? So I will divide 2 by 2 to get 1 inch. Now remember, whatever I do to the top of my fraction or the top of my ratio, I must do to the bottom. So I must do 3 divided by 2. Well, if I have 3 candy bars and I'm splitting it with 2 people, I'm getting 1.5 or 1.5. So 1 inch is the same. 1 inch on the drawing is the similar version for the actual wall of 1.5 feet. So for every 1 inch on the drawing, that represents 1.5 feet on the actual wall. So the reason I went down to that 1 unit measure is because that makes the next part nice and easy. So now that I know that 1 inch represents 1.5 feet by making a unit rate out of the scale factor, I will compare that to the length. So my scale factor is now 1 inch is representing 1.5 feet. I want to know what 28 inches is. That is the length in feet. Equivalent ratios, right? Now, if this is at 1, that makes it easy. What times 1 gives me some 28? 28 does. So I'm going to do 28 also times 1.5, and that's going to give me the answer of how many feet. And by the way, that ends up being 42. So I now know that the actual wall will be 42 feet long. I will use the same scale factor, because it's the same scale factor that we're using for this. And now I will compare it with the height, which is 11 inches. Well, what do I do to 1 to make it become 11? Multiply by 11, right? So do the same, multiply by 11 to the bottom of the ratio. And that is going to be 16.5. 1.5 times 11 is 16.5. And that's the feet that it represents. So we're going to put 16.5 feet. So that gave us the calculation for the length and the height in the actual wall. Okay. Again, the question was, what is the area of the actual wall? Now I have the feet measurement of the actual wall, so I can just do the area equals length of 42 times the width. In this case, it's the height, 16.5. I multiply that all together, and that's going to be 693 feet squared. So all those steps to do that, but they're not complex, and as you practice them, you'll see that they all fall together pretty well. Steps being, get the unit rate of your scale factor using the unit that you're changing it from. After that, just compare that unit rate at almost like a equivalent fraction and force it into that amount. So what do you have to multiply that 1 unit by to get the amount that you already had? Oh, okay, then do the same to the bottom, okay? Or to the other part of the ratio. So with practice, hopefully that's pretty clear. And as I said, with practice, this will become more clear. I'm going to walk you through this next one too. Feel free to be adventurous and try it, pause, and then try it, and then push play if you get stuck, or play push play if you get the answer and you want to see if it's correct. The drawing for an art studio shows a rectangle that is 13.2 inches by 6 inches. The scale in the plan is 3 inches to 5 feet. Find the length and width of the actual studio, and then find the area of the actual studio. So ultimately, I want the area. In order to do that, I will need to find the length of the actual studio. Okay, circle the information they gave us. The rectangle is 13.2 inches by 6 inches. Let's draw that. This is the drawing plan. So it's the small one, 13.2 inches by 6 inches. Okay? And of course, we're going to have a great big wall or floor or something. It's the studio. We just don't know how many feet by how many feet. But when we do know, we'll be able to find the length, width, and multiply them together for the area. Okay. The other piece of information that's very, very important is this scale factor they give us here. 3 inches is 5 feet. It really looks confusing there. That's why I like it to be as a fraction. 3 inches is 5 feet, but you'll get used to seeing it either way. Okay. Let's break that down to the scale factor. It is in inches. We know the inches ones. We want to know the feet one. So let's get inches down to its unit rate. That's going to be a divide by 3 to both, which will give us 1 inch is how many feet? And it comes out to be 1.666 repeating. I'm just going to round it to 1.67 feet. Okay. Now that I have that scale factor in its unit rate form, all I have to do is compare it to its length and then also its width. So this scale factor compared to 13.2, obviously, in order to get 1 to become 13.2, I have to multiply by 13.2. You can see now why it was important to bring it down to unit rate. You get decimals and fractions in there, it gets confusing. So it's easy this way. 1 times 13.2 is what gives me 13.2. So I will multiply this by 13.2 as well. I'm just going to do it on the calculator. It comes out to 22.044, 22. I'm just going to round it to 22.04. I keep things in the hundredths place generally, or to the pennies place. My width, 1 inch, is 1.67 feet. Oh, this is feet, by the way, of my actual length. And my width over here is 6 inches. So how did I get from 1 to 6? 1 times 6 is 6, right? So times 6 here, then do times 6 here, and I get 10.02 feet. So what I have found out is that I have a height or a width of 10.02 and a length of 22.04. And they wanted me to find the area. Now I know the length and the width, 22.04 times 10.02. And the answer I get is 220.8408. I'm just rounding, like I said, I just keep it to the pennies place, unless it tells me otherwise. I didn't see where they said I need to round it to any place value. So I'm just going to leave it at the hundredths place. 220.84 feet squared should be your answer. And if you look at the answer book in the teacher's book, it says answer is 220 feet square. So I rounded it to the hundredths place, but it appears as they went through, they just kept rounding it to the ones place, 1 full foot. So we were just a little more precise on ours. That's all. But that's the steps. Those are all the steps. Take your scale factor, make it into a unit rate with the 1 unit being the unit you're changing it from. Then compare those ratios and use equivalent fractions to build it back up compared to what you have, and then multiply it by that to get what you need to know. You find it. Do the same with the width. If there's 2 pieces to do it with, then do the same with the width. Okay, so this explore activity helps you kind of wrap your head around what's going on a little bit, what's happening with your scale factors, and especially if you're looking at different scales. So we have a scale drawing of a meeting hall drawn on centimeter grid paper. So each of these represents a centimeter. And the scale here shows that 1 centimeter is the equivalent of 3 meters. So 3 meters, 3 meters, 3 meters, 3 meters, 3 meters, right? 1, 2, 3, 4, 5, 6, 7, 8 centimeters. 3 would be 24 meters, just so that we could see that. Okay. They say, suppose you redraw the rectangle on the centimeter grid paper using a scale of 1 centimeter is the equivalent of 6 meters, or is representation. I guess I shouldn't say equivalent, I should say is representing 6 meters. So in the new scale that we're using, it represents more per 1 centimeter than it does in the old scale. So if we're going to be eating up, if every 1 centimeter gives me 6 meters, then I've got 1 centimeter gives me 6, 12, 18, 24. So my drawing is going to be twice as much or half as much. Is it going to be bigger, twice as big, or smaller, half as big if it's covering more ground? Right, you're right. It's going to be half as long as the measurement of the original drawing. So the 1 centimeter to 3 meter ended up being bigger because each of those centimeters eats up less ground, 3, 6, 9, 12, blah, 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 right? Then this one's 1 centimeter. That covers 6 meters for each 1 centimeter. So let's draw it out. 1 centimeter is 6 meters. So we have 6, 12, 18, 24. And then we've got to do the height too. This was 1, 2, 3, 4, 5, 6. So that's 1 times, that's 6 centimeters. And then that's, this was in threes, right? So 6 times 3 is 24. I mean, 6 times 3 is 18. I know that 6 times 3 is 18. 6 times 3 is 18 from here to here. Well, on this one, we're doing, we're going to get to 18 meters. Let's count by sixes, though, because this scale is by sixes. 6, 12, 18. Then make it the rectangle like it is. And you notice that's half the size. Not even half the size, it's a quarter of the size. The length is half as long, but the whole thing itself ends up being a quarter of the size. I feel like I want to do one more with you before I send you on your way. I put the steps here. You're going to take that scale factor and put it down to the unit rate of the from label. What is going from is the number, is the 1 value for the unit. And then after that, you'll just use equivalent fractions to bump it back to where you want it to be. The scale in the drawing is 2 inches represents 4 feet. What are the length and width of the actual room? So we have a drawing. That's the size the room's going to be. And they want to know what the length and width of the actual room are. And then when we know that, then we can find the area. So we need the area. I'm going to put this message to myself over here. Don't forget, I need to do length times width when I know the length and the width of the actual room. They want me to find the length and the width of the actual room, which is great because I have to find it anyway to find the area. The scale factor they gave me is 2 inches represents 4 feet. Okay, there's my scale factor. I want it in a unit rate form with the measurement that I am moving from, and I'm moving from inches, and that because that's the information they gave me. They gave me in inches. That's what I'm going from, and I'm trying to turn it into feet. So we're going to turn this one into its unit rate of 1. So how do I get 2 to become a 1? 2 divided by 2, right? All of those calculations jump out at you pretty quickly because you're just dealing with those identity property with ones. Sorry, divide by 2. Divide by 2. 2 divided by 2 is 1. And 4 divided by 2 is 2. So in a unit rate form, 1 inch represents 2 feet. That will make my calculations easier. So I'm going to use that unit rate scaled factor for both of my calculations. 1 inches is 2 feet. And I'll just find the equivalent fraction for both the length and the width. For the length, 14 inches. For the width, 7 inches. I got that from right here. 14 inches, 7 inches. Okay. Well, easy calculations, right? What do I do to 1 to get him to become 14? Multiply by 14. So I also must multiply the denominator by 14. 2 times 14 is 28. So the room is 28 feet in length. What do I do to 1 to get him to become a 7? Multiply by 7. So multiply the denominator by 7 as well. 2 times 7 is 14. So the width of the room is 14 feet. Now I can simply find the area by doing 28 times 14, and that is 392 feet squared area. So my length, they asked me the length, 28 feet. Width of the actual room will be 14 feet, and the area will be 392 feet squared. So that's how you do that. There's the steps. You may want to copy them down if that was helpful, if they made sense and they were helpful. But those are the only steps involved. So good luck with this. Practice makes you understand it even better. I know you've got this.